Welcome back. In my previous videos, I had done the basics of linear equation, activity 10, 11, and 12 from SpringBoard Course 3. This video is about activity 13 from SpringBoard Course 3. Activity 13 is about real-world problems and proportional relationships. In this section, we will need to model the problem. To model the problem means to identify the fixed variable, then to identify the dependent variable, and then to derive the slope, which is the rate of change, or m, and to identify the y-intercept, or the b. And then you come to the formula of y equals mx plus b, and that formula is for non-proportional relationships. So this is the formula, y equals mx plus b, and the graph of y equals mx plus b would look something like this. And the line in the graph would not pass to the origin. So, and then if the two variables are directly proportional, then the formula would be y equals mx, and the graph of that would look somewhat like this. It would pass to the origin and then go straight up. And also, in directly proportional, if we double y, it will also double x. So let's get started with activity 13, lesson 13-1, and page number 161. So let's read this little scenario before we start. The scenario says, Scarlett is spending her summer afternoon as a junior lifeguard at the local pool. Each afternoon she works, she is paid $10 plus $2 per hour. So we should probably circle this because this is important information. In the evening, she's umpiring for a recreation softball league at the local community center. They pay her $4 for each hour she works. So we should probably also underline this because this is important. So this problem means that Scarlett is doing two of these jobs. So the first job is So let's model the situation of Scarlett's two jobs. So Scarlett's first job is being a lifeguard. So lifeguard. And her second job is umpiring. So let's put that on the other column, and let's create two columns. Okay, so let's model lifeguard first, and then we'll model umpiring. So for lifeguard, she gets $2 for every hour, and she gets a fixed rate of $1.10 for every time she goes there. So this is our fixed rate. So then, since this is our variable cost, because it keeps on changing, her variable salary, so this would be our m, because slope also changes by constant difference. So this would be our m, and this would be our b, because b is our y-intercept, and y-intercept doesn't change. So this would be our b. So our next step is to derive an equation from this to model Scarlett's earning, and we can do that by y equals 2x plus 10. We did that because since 10 is b, since it's a fixed rate and b doesn't change, we put 10 in place of b, and since 2, it changes since for every hour she does, and x is the number of hours she works, so that's why 2x will model how much she gets per hour. And so this is our equation we derived for Scarlett. We get a $2 per hour as our slope from the question over here when it says she is paid $10 plus $2 per hour. That's how we get our slope. And then we get our y-intercept because it says we get $10 is our fixed rate. We get the y-intercept because it says she's paid $10. That's why we get our y-intercept from there. And then our y is the total salary she receives for every afternoon she works, and x is the number of hours she works. So this is the number of hours. and this is her total salary. So let's model her next job. So for her next job in the question, it says they pay her $4 for every hour. So as you can see here, there's no fixed rate. So let's just write that. She gets $4 per hour. $4 per hour. And then we know that this is our slope. So as we can see in the problem, they say that they pay her $1 for each hour. They don't say any other fixed rate, so that means there's no y-intercept in this problem. So our equation for the problem would be y equals 4x, and x would be the number of hours worked, and y would be her total salary. And since we have modeled her Scarlett's 2 jobs, let's continue on with number 1. So number 1 says, which job do you think? So for number 1, we have created. For number 1, let's refer back to our equations we made over here. So if you plug in any numbers from 0 through 5, this is the better option, lifeguarding, because it pays an additional fee of $10. So if you think about it, it pays more. So for this, we should create a table to see which job is more suitable for Scarlett, and then we can answer number 1 on page 161. So let's make a table of values for number 1. So this is our x. X will be the number of hours that we have up here. So this will be our x. And this will be y1. And y1 will be the total salary for lifeguard. So let's just write lifeguard over here so we don't get confused. And y2 will be our salary for umpiring. So let's write that so we don't get confused. And then let's compare which jobs is good for Scarlett. So since we can't have negative hours because all time has to be positive, so let's start with 0 hours and let's do till 6. So let's start with 0. 0, 1, 2, 3, 4, 5, and 6. So we created our table, and then let's plug in 0 in this equation. We find out that y1 is 10. If you plug in 0 in this equation, we find out y is 0. Plug in 1 in this equation, we find out y1 is 12. We plug in 1 in this equation, we find out it's 4. And let's continue on the table. So this is 14, this is 8, this is 16, and this is 12, and this is 18, and this is 16, and on 5, they both equal 20. So, and then let's see number 6. So number 6, this equals 32, and this equals, not 32, 22, I'm sorry, and this equals 24. So we see till number 5 that, on number 5, these two equal the same, and till 0 to 4, lifeguarding is the better choice, and from 5 onwards, umpiring is a better choice. So let's go back to the question, number 1. So I wrote as my answer, if she's planning to work less than or equal to 5 hours, lifeguarding is a good choice. If she wants to work more than or equal to 5 hours, umpiring is a good choice. And I derived that solution based on my table right here. So let's move on to number 2. Number 2 says Scarlett wants to determine how much money she can possibly save by the end of summer. To do this, she creates a table to track her earnings. Complete each of the 2 tables below to track Scarlett's earnings for the first 5 hours she works at the job. So you can just copy, since you have created the table right here, which is kind of similar to what that table is. So you can just copy these values from this y1, and then you can copy this values over here from y2. So since we're done with number 2, let's move on to the next page, which is page 162, lesson 13-1 and activity 13. So let's go to number 3. Number 3 says, do the earnings from either jobs have a constant rate of change? Explain your response. Share your ideas with a partner or in a group. We're not going to do this because we don't have a group with us right now. So let's just focus on this first sentence on the top. So, do either jobs have constant rate of change? So let's look back at our equation we have here. So, at our equation, we see that this one has an m and this one has an m. So that means that these both have slopes. So the answer to number 3 is gonna be yes, because they both increase by the same number each r, which is for lifeguarding, which is 2, and for umpiring, which is 4. So let's go to number 4. Number 4 says consider Scarlett's job as a junior lifeguard. So let's go to 4a. 4a says write an equation that could be used to determine the amount of money y that Scarlett would earn x for x hours working at the pool. So we already derived that equation, and that equation is y equals 2x plus 10. So you can write that equation right here for 4a. Let's go to 4b. 4b says identify the slope in the equation and explain its meaning in the problem situation. So we can see our slope is 2. So 2 is the slope, and it means for every hour she works, she gets $2. We know that because since it's a coefficient of x, and x means number of hours worked, that means she'd get $2 for every hour worked. Let's move on to 4c. 4c says identify the y-intercept in the equation and explain its meaning in the problem situation. So our y equation is $10, and we can interpret its meaning in the problem situation, and that would be it means she gets $10 for joining. And it says that because over here it says she gets paid $10 plus $2 per hour. So this is a fee for joining for one afternoon, and that information is on page 161, the previous page. So since we're done with number 4, let's move on to number 5. Consider Scarlett's job as an umpire. So 5a. Write an equation that could be used to determine the amount of money y that Scarlett would earn in x hours working as an umpire. So we already derived that equation, which is y equals 4x. So you can write the same equation over here. So let's move on to 5b. 5b says identify the slope in the equation and explain its meaning in the problem situation. So our slope is 4, and it means for every hour she works, she gets $4. And that is because it's a coefficient of x, and x is the number of hours worked. So she would get $4 for every hour worked. So let's see what 5c says. 5c says identify the y-intercept in the equation and explain its meaning in the problem situation. So we see that there is no y-intercept here. So the y-intercept must be 0, and that means she doesn't get any money for joining. So that would be our problem situation. So our answer for 5c would be y-intercept is 0, 0, and it means she doesn't get any money for joining. So let's move on to the next page, which is page 162. 163, activity 13, lesson 13-1. So we don't need to listen to a group or a class discussion. We can just do this part on our own. So let's move on to number 6. Number 6 says describe the similarities and differences in the equation for two jobs. How are the similarities and differences exemplified in the table for two jobs? So some similarities are that they both are linear, and and at 5 hours both jobs pay the same. And that is because in the table that we saw that for 5 hours, when x equals 5, y1 and y2 both equal 20. And a difference would be that only one of them is proportional, and that is, you can see that because when x equals 0, lifeguard, which is y1, equals 10, but umpiring, which is y2, equals 0. So umpiring is the only directly proportional in this situation. And lifeguarding has an extra payment of $10, while the umpiring doesn't. So this is what I meant by the which one's directly proportional. So let's move on to number 7. Number 7 says graph the representing graph the lines representing Scarlett's 2 jobs on the grid provided. Be sure to label the axis and include a title for each graph. By labeling the axis, it means that putting a subtitle on the sides of the 2 graphs. So, first, you can use this table that you have created to plot your points and then connect the line, and the title of the first graph would be money provided as a junior lifeguard. That's because, or you could switch it around. You could say money provided as an umpire, but I did junior lifeguard here because I plotted junior lifeguard over here, and umpiring over here because I plotted umpiring over here. So, and then I put hours worked as my X and the dollars earned as my Y over here. So let's move on to number 8. Number 8 says, compare and contrast the 2 graphs. How do the similarities and differences in the graph relate to the equation table? Well, both graphs are linear, and we can see that because in the table that they all increase by a constant number. That is 2 for lifeguard and 4 for umpiring. And the equation, we see it's increasing by 4, increasing by 2, and only one of them is directly proportional. And we can see that because in the equation, this doesn't have a y-intercept, while this has a y-intercept of 0, 10. And we can see that in the table because when x equals 0, lifeguard equals 10, and umpiring equals 0. And these are the similarities and differences in the table, graphs, and equation. So let's move on to number 9. Number 9 says, if Scarlett doubled the amount of money she worked at the pool, would she double the amount of money she made? Explain using examples. No, and that would be because over here in the table that I drew, so I just picked 3 values, which is 0, 1, and 2. So for 0, she would get $10, for 1, she would get 12, and for 2, she would get 14. So as you can see, when x doubles, y doesn't double. So 1 is a double of 2, so this doubled, x doubled. Well, when you see y doesn't double because 12 is not a double of 14. So let's move on to the next page, which is page 164, activity 13, lesson 13-2. So let's go to number 10. Number 10 says, if she doubled the amount of money she worked as an umpire at the community center, would Scarlett double the amount of money she made? Explain using examples. So, she would actually double her money because if you see the table I drew, for x, I took the values 0, 1, and 2. For y, I took 0, 4, and 8. So, when 1 is a double of 2, like 2 is a double of 1, so when you double 1, you get 2, so x is doubled, and 8 is the double of 4, so when you double 4 you get 8, and that's true. So number 10's answer is yes. So let's move on to check your understanding. So use the 2 data tables below for items 11 through 14. So we have to use these 2 data tables. Let's see number 11. Number 11 says draw a graph for each data table. Be sure to label the axis. So you can just draw a graph on the My Notes section, and then you can just plot the points and connect the line. So let's move on to number 12. Number 12 says write the equation for each graph. Well, the equation for this would be y equals 3x plus 1 because it's increasing by 3 each time, and if you think about it, so for 0, it would have to decrease by 3. So 4 subtract 3 is 1. So for this, it would be y equals 3x plus 1. And for this, the slope is also 3, but then for when x is 1, y is 3. So if you subtract 3 for 0, then you would get 0. So there's no y-intercept over here. So let's move on to number 13. Number 13 says consider graph A, or you could also consider table A. I would prefer you consider table A because graphs are not that hard to, do problems with. So let's consider table A. So 13A, what is the slope of the table? We already determined the slope is 3 because it increases by 3 each time. Where's the y-intercept? We determined it's 1 because when x is 0, y is 1. And what does the value when the value of x doubles, does the value of y double too? No, because 2 is a double of 1. So when you double 1, you get 2, but when you double 4, you get 8, not 7. So this is no. Let's move on to number 14. Number 14 says consider a graph B. For this, we're going to do the same thing as above. We're going to consider a table B instead of the graph B. So 14a, what is the slope? We already determined the slope is 3. 14b, what is the y-intercept? The y-intercept is 0 because when x equals 0, y equals 0 too. So let's move on to 14c. 14c says when the value of x doubles, does the value of y double? So that it does double because if you double 1, you get 2, and if you double 3, you get 6. So the answer to this is yes. Let's move on to lesson 13-1 practice. So let's read the problem scenario before starting. The problem scenario is Nina wants to sign up for swim classes. The school charges $6 per visit. We should probably underline this because this is important information. The recreation center charges an initial fee of $15 plus $3 per visit. So this is also important information. So basically, the problem means that Nina wants to join swim class. So she has two options. So her first option is her school. So let's create a column because we should model this situation too. So her first option is the school. And her second option is her recreation center. So I'm just going to write center because this is going to take too much space if I write recreation and center. So I'm just going to write center. So for scenario 1, if she wants to attend swim classes school, we only know the slope because there's no y-intercept, there's no additional fees, there's only the $6 per visit. So over here, there's only $6 per visit. So this is our slope. So we only know the 6 is our slope. $6 is our slope. We don't know anything else. And for the recreation center, we know that she'll get she has to pay an initial fee of $15 plus $3 per visit. So we know two things: the slope and the y-intercept. So the B, which is the y-intercept, is $15 because she has to pay additional money for that, and our M is our $3 because she has to pay that every visit. So let's create an equation for both of these. For this, since we only know the M, our equation derived would be y equals 6x. X would be the number of visits she goes to swim classes in school, and y would be the total money she has to pay. So this would be visits, number of visits, and this would be the total cost. And equation derived from the recreation center would be y equals 3x plus 15. X would be the number of visits, and y would be the total cost. So let's move on, and then 15 would be the one-time fee she would have to pay. So let's move on to number 15. Number 15 says complete a table to show the cost of lessons at school and the center. So let's do a school first. So since we have an equation for school right here, we can just put the number of visits in the equation over here in the x value, and then you can find the y, which is the cost in dollars. And you can do the same for the recreation center swim classes, and you put the number of visits in the equation right here in the x value, and then you can put the cost in dollars over here, which is what we are y. So let's do 16. 16a says, write an equation that can be used to find the total cost y for the number of visits x at the school swim class for item 15. We already did that because we already derived the equation. We can write this thing for 16a, which I wrote right here. And let's do 16b. 16b says, write an equation that can be used to find the total cost y for the number of visits x at the recreation center swim classes from item 15. We already did that because this is our equation right here, and you can write the same thing for 16b. So let's move on to the next page, which is page 165, activity 13, lesson 13-1. let's move on to 17. A and B, they are the same question almost. It says graph the equation you wrote in item 16A, which are labeled axis. And for 17B, it's graphing the equation you wrote in item 16B and labeled axis. I'm not gonna do this problem for you guys, and I want you guys to do it on your own because you already had a little practice with this on item 11. So it's the same thing almost. So you guys can do that, but for number 17. So we'll skip number 17 and we'll go to number 18. Number 18a says, use the graphs in 17a to find a slope and a y-intercept. You could also find a slope and a y-intercept from the equation, and that's what I did. So for 17a, for 18a, I got 6 as my slope and 0, 0 as my y-intercept. So that's what I wrote over here. And for 17b, I got 3 as my slope and 0, 15 as my y-intercept. That's what I wrote here. So let's do 19. 19 says, using the information in item 15 to 18, where should Nina take her swim classes? Well, you can explain that on your own, that after that she should take her class at the swim class or school swim classes or recreation. You can decide that on your own based on what we did till now and how we model the situation. I think you guys should be able to do this on your own. So we'll skip that and we'll go to number 20. Number 20 says, Rianne wrote the equation for the graph shown as y equals a half x. Do you agree or disagree, Rianne? Explain your reasoning. So, this is not the graph for y equals a half x because for this, there's no y-intercept here. Well, over here in this graph, this has a y-intercept of 4. So, what I wrote is no, because the y-intercept is supposed to be 0, 0, but in this graph, it's 4. So that's why Rianne is wrong. So let's move on to the next page, which is page 166, lesson 13-2, activity 13. So, let's read this first, and then we'll read the math term, and then we'll continue. So, okay, so first let's read this. If changing one variable in the equation by a factor causes the other variable to change by the same factor, we can say that two variables are directly proportional, and this is highlighted in bold because this is a word you need to know. And call the equation relating the two variables a direct variation. You also need to know this word because it's pretty important. Direct variation equation. Direct variation relationships describe many real-life situations. So let's read the math term. A direct variation is a relationship between two variables, x and y, that can be written in the form y equals kx, where k is any constant other than 0. Direct variation equations are linear equations. So, let's do some try these 8. Determine whether the relationship between the variable in the following equation is directly proportional or not. Explain your reasoning. So, for this, it is directly proportional because one, if you double this x, you also double y. We get this rule because it says up there, if one factor causes the other to change the variable to change by the same factor, that's how we get this. If you double x, you can also double y. But in B, no, because it's not directly proportional, because if you double x, you don't double y because there is a y-intercept and that doesn't let you double it. So let's move on to number 1. Number 1 says, consider tables, graphs, and equations for Scarlett's 2 jobs in the previous lesson. Which of her jobs is the example of direct proportional relationship? Justify your response to evidence from table, graph, and equation. So let's go back and let's see from this binder paper. So we see that if we double x over here, you don't double y, because look at the table down below. So 10, you don't double it to 12, 12 you don't double it to 14, while 4 you double it to 8. So implying this is the job that is directly proportional. So let's write that. Empowering is the directly proportional job, and that is because I took a part of the table and I put it here. So 0, 1, 2 is my x values, and my y value is 0, 4, 8. And as you can see, 8 is a double of 4, so if we double 4, yes, y is doubled, and 2 is a double of 1, so if we double 1, so is x. So this is why empowering is the directly proportional relationship. So let's move on to 2. So it says create a table and equation and a graph for each of the following situations. So let's read all these A, B, and C situations, and then we'll continue with our questions. So it says the distance Lily walks in is 2 times the number of minutes she has been walking. So it's 2 times the number of minutes. You should probably circle this because this will be important. And situation B says the distance traveled by the rabbit in the critter race is consistently 1 inch more than twice the distance traveled by the iguana. So 1 inch more than twice the distance. Situation C says the amount of water in the pitcher is half the times elapsed in seconds. So it's half the time. So let's create a table let's model in the situation A in a table. So since it's 2 times the number of minutes walked, so x will be a number of minutes, and y will be the output, means how many times number of minutes she's walked. So the distance she's walked. So if she has walked 1 minute, she'll walk a distance of 2. If she's walked 2 minutes, she'll walk a distance of 4, and so on till number 5. When x till equals 5. And for situation B, it says 1 inch more than twice the distance. So this will be x will be the distance traveled by the iguana, and this will be the distance traveled by the rabbit. So if 1's the distance traveled by the iguana, then 2 times 1 is 2 plus 1 is 3. And if we do x equals 4, x equals 2, then it's 2 times 2 is 4 plus 1 is 5, and then you can continue on till x equals 5. So let's model situation C. For situation C, it's half the time half the time in seconds. So for 1 second, half of 1 second is 0.5 seconds. And let's take 2 seconds. So half of 2 seconds is 1 second. And then you can continue this pattern on till when x equals 5. And then you can take these points and then graph them on this graph right here. You can just take these points, plot them, and then get a ruler. And then by looking at these graphs, you can derive an equation. So since the slope of this graph is 2, and it doesn't have a y-intercept because it passes through the origin right here, so the equation for this would be y equals 2x. For this, it has a y-intercept of 1, and it has a slope of 2, so the equation for this would be y equals 2x plus 1. And for this, since it passes through the origin, it won't have a y-intercept, but it will have a slope of half. So let's move on to 2b. 2b says write a conjure about the y-intercept of the directly proportional relationship. So only these two are directly proportional, and a similarity you notice in this is that they don't have any y-intercepts. So that would be, or they would have y-intercept of 0, 0, and the graph would pass to the origin. So for our answer to 2b would be the y-intercept is always 0, 0, or there's no y-intercept. So let's continue on to the next page, which is page 168, lesson 13-2, activity 13. Let's begin with number 3. Number 3 says, which of the situations in item 2 are examples of directly proportional relationships? Justify your response. So if we go back here, we see that these two are directly proportional because they have a y-intercept of 0, 0. So a situation A and situation C are directly proportional. So that's what we write over here. And our justification would be the graphs pass through the origin. So let's do the check your understanding. Determine whether each of the following is an example of a directly proportional relationship or not. Explain your reasoning. So let's read number 4. Number 4 says, Michael eats 3 pieces of fruit each day. So this is an example of directly proportional relationship because if you double x, you also double y. Because if you double the amount of days, you also double the amount of fruit he eats. So let's move on to number 5. Number 5 says admission to the school carnival costs $5 plus 0.75 cents per ride. So, 75 cents per ride. So this is not a proportional relationship because this has a y-intercept of 0, 5, and we already discussed in the previous page, page 157, 2b, that directly proportional relationships don't have a y-intercept. So since this problem, number 5, has a y-intercept, it's not a directly proportional relationship. Let's see number 6. Number 6 is not a directly proportional relationship because you can't convert this into a y equals mx format, or even y equals mx plus b, where b equals 0. You can't convert this into that format, so this is not a directly proportional relationship. So let's move on to number 7. Number 7 is not a directly proportional relationship. You can see that because if we double x, you don't double y, because this does not equal 64. This equals 128, which is not a double of 32. So let's move on to number 8. Number 8 is not a directly proportional relationship, and that is because there's no points or a line to see if this graph is directly proportional. This is just an empty graph, but you could argue it's directly proportional, but in my opinion it's not, because there's no points to or a line to see if this graph is directly proportional or not. So let's move on to number 9. Number 9 says, Kira believes that the following graph shows a direct proportional relationship. Kwame disagrees. Who is correct? Just for a response. Well, this is since we know that directly proportional relationships have to pass to the origin, and since this graph doesn't, Kwame is correct because he says that this is not directly proportional, and that's true because this has a y-intercept of 0, 3. So let's move on to the next page, which is page 169, activity 13, lesson 13-2. So let's read a little bit of this and then we'll continue on the questions. So it says direct variation equations can be written in the form y equals kx. The value of k is in the equation y equals kx is called a constant variation. This is a really important vocabulary you guys should know, or the constant proportionality. You could choose either one of this and make sure you know this vocabulary. So let's use number 10. Number 10 says, use your tables, graphs, and equations from item 2 to explain the relationship between the constant variation and the rate of change and the slope of the graph. We learned so much about constant variation, slope, and rate of change that you should be able to answer this. And just in case if you don't know or you forgot, number 2 is on page 162. So you can use this thing to answer, and we have learned so much about slope. I know that you guys will be able to do this on your own. So let's go to number 11. Number 11 says, direct variation equations are often used to solve real-world problems. We already know this when we started this activity. In each of the following, determine the value of k, write an equation in the form of y equals kx to represent the situation, and then use the equation to solve. So we have to do 3 things here. First, we have to find the value of k, and then we have to write an equation, and then we have to use the equation to solve the problem. So we have 3 things that we have to do. So let's move on to 11a. 11a says, the Chumas family is driving from North Carolina to California on vacation. They drive 330 miles in 5 hours. How many hours would it take for them to drive 720 miles? So first, what we do is, this is our x and this is our y. We have to find m in this situation. So we would write, first we would write our original equation, and then we would write 330 equals m and 5.5. Okay, so we have to find m in this. So we divide by 5.5 on both sides, and then we equal with m equals 60. And we know that since k is the slope in the situation y equals kx, and so is m, so our k would be 60. So this is how we get the k is 60. So then we have to write an equation in form of y equals kx or mx. It's the same thing except you're just changing the variable. So our equation would be y equals 60x. So that's what we write here. And then we have to solve for 720. So we substitute in 720 for y, and then we solve for x. We divide 60 on both sides, and then we equal with y equals 12 hours. And make sure to put the units because this is a real world problem. So let's move on to the next page, which is page 170, lesson 13-2, activity 13. So let's move on to 11b. 11b says many animals age more rapidly than humans do. The chart below shows equivalent ages for dogs and humans. What is the equivalent dog age for a human who is 16-year-old? So we have to use this table. So first we have to find k. We find k because it's a slope, and we see that it's increasing by 7 each time, so our k would be 7. And then since the equation we have to derive from it, y equals kx, so we just put k over here and we get the equation y equals 7x. So then we had to solve for what is the dog age for a human who's 16-year-old. So since we know that y is our human age and x is our dog age, we put 16 in place of y. We substitute in 16 for y, and then our equation is 16 equals 7x. Then we divide 7 from both sides, and we come up with x equals 2 and 2 7 years old, and so the dog will be 2 and 2 7 years old. So now let's do the check your understanding. So let's read the problem situation first. It says Ellen is training to compete in a half marathon. She currently runs at a rate of 4.5 miles per hour. So basically, this problem means that Ellen is running a half marathon, and the distance she wants to cover depends upon the rate of her speed. So the distance covered would be your y, and your x would be the duration she ran for. So let's write an equation for that. That would be y equals 4.5x, where x would be number of hours she ran, and this would be the total distance covered. So let's move on to 12a. 12a says create a table and a graph showing Ellen's distance as it relates to the amount of time she runs. We had a lot of practice with this in previous pages, like page 167, number 2a. So I'm pretty sure you guys can do it in page 170, 12a too. So let's move on to 12b. 12b says write an equation to represent the relationship between the time she runs and the distance she runs. We already found that equation right here when you model the problem, so you can just copy this equation right here. So let's move on to 12c. 12c says, is the equation from part B a direct variation equation? Explain your reasoning. It is a direct variation equation because there is no y-intercept over here, so that's why it's a direct variation equation. So let's move on to 12d. 12d says if Ellen runs 13.1 miles to complete the half marathon, how long will it take for her to finish? So we know that if we go back here to the modeled equation, we know that y is the total distance she runs, so we have to find x. So then you substitute in 13 for y, so this will be our equation. 13.1 equals 4.5x, and then you divide 4.5 from both sides, and then you find the value of x. So you can divide this on your own and then solve for x. So let's move on to the next page, which is page 170, activity 13, lesson 13-2. So this is the lesson 13-2 practice. So for each representation below, tell whether the relationship is directly proportional or non-proportional. So let's see this graph. Does the graph pass to the origin over here? It doesn't. So then it's a non-proportional relationship. So let's go to 14. 14, let's see. Let's see the y-intercept. The y-intercept is 0, 0, and it's increasing by constant speed. So it is proportional because if you double x, you also double y. Because 4 is a double of 2, and 400 is a double of 200. So this is proportional. Let's go to number 15. Number 15 says, number 15's equation is y equals 1/3 x. We see that there's no y-intercept here, and for 1, if you plug in x as 1, then you get 1/3. If you plug in x as 2, you get 2/3. And we know that 2/3 is a double of 1/3, and 2 is a double of 1, so 15 is a proportional relationship, directly proportional relationship. Let me write that. And also 14 is a directly proportional relationship. And these are non-directly proportional relationships. So let's go to 16. 16's equation is d equals 50 plus 10h. So 50 is our y-intercept, and we know that directly proportional relationships don't have y-intercepts, so this would be a non-proportional relationship. So number 17 also has a y-intercept, as you can see, when x equals 0, y equals 1, so this will be a non-directly proportional relationship. So let's see number 18. Number 18 says Loop reads 12 pages of her book every night. So this is a proportional relationship because for one night she'll read 12 pages, for 2 nights she'll read 24 pages, and 24 is a double of 12, so this is a proportional relationship, and for 0 nights she will read 0 pages of books. So let's read number 15, the problem, and then we'll see. Miss Tandy pays a $50 registration fee to join fitness club. She pays a monthly rate of $25. Write an equation to represent the total Miss Tandy pays for a fitness club for X months. Determine if the equation represents a proportional relationship or non-proportional relationship. Explain your reasoning. So our equation we would derive from this, since $50 is the registration fee for one time to join, and then since you don't join multiple times, you only join once, she only has to pay that once, and she has to pay a monthly rate of 25, so every month she has to pay that. So 25 would be our m, and 50 would be our b, so our equation would look like y equals 25x plus 50, and this is a non-proportional relationship because this has a y-intercept of 0, 50. So let's move on to the next page, which is page 173, activity 13, and this is activity 13 practice. So let's move on to 1a, and let's read the situation first before doing the question. It says, consider following equations: a, y equals 2x plus 4, and b, y equals 2x. So let's see what number 1 says. Number 1 says, what are the slope and the y-intercept for the equation A? So our slope is 2, and our y-intercept is 0, 4. Let's see what 1b says. What is the slope and the y-intercept of equation B? Our slope is this, and since we don't have y-intercept here, our y-intercept would be 0, 0. So let's see number 2. Number 2 says, we can type 25 words per minute. Create a table that represents the speed at which we can type. We have had a lot of practice with creating a table, so I'm pretty sure you guys can do that. 2b says graph the data. You guys can also do that because we had a lot of practice with graphing, and we saw a lot of graphs in this activity. So let's see 2c. 2c says write an equation that represents the relationship between the number of words we can type in his typing speed. Well, you guys can do this on your own, and it's y equals 25x because since there's a y-intercept, and plus our m is 25 because he types that many words per minute. And our 2D, let's read it. What is the slope of the equation you want in part C? We know the slope is 25 because that's a coefficient of x, plus the slope, you know what it represents, the words typed per minute. And let's see, 2E, what's the y-intercept of what you write in part C? Well, since there's no y-intercept, then our y-intercept would be 0, 0, and that would be in 0 minutes he would type 0 words. So let's go on to part C, question number C. So question number C, as I'm looking at it, is the same thing as question 2. We'll still read through this. I'll give you a little hints, but I want you guys to solve 3 on your own like you guys did with number 2. So Ashledge is hiking at a rate of 4 miles per hour. Create a table to represent his distance after 1, 2, 3, 4, and 5 hours of hiking. So it's the same as 2A. If you guys can do that, you guys can also do 3A. So 3B says graph the data, so that's the same as 2B. So let's go to 3C. 3C says write an equation that represents the relationship between the time and her distance. Well, that's the same, almost the same as 2C, so you guys can do that on your own too. So 3D says, where's the slope of the equation we wrote in part C? What does the slope represent in this situation? That's the exact same thing as 2D, so you guys could also do that on your own. And I've gone through this with you guys, so you guys could do this on your own too. So 3E says, where's the y-intercept of the equation you wrote in part C? What does the y-intercept represent in this situation? Well, it's the same thing as this, so if you can do this, you can also do this. So let's read this problem situation before starting number 4. Number 4 says, the table shows summer jobs earning for Carolina and Monica. Use these tables for item 4. So this is Caroline's earnings, and this is Monica's earnings. So let's see number 4. Number 4 says, which equation shows the relationship between the hours Carolina works X and her earnings Y? So let's look back at her. So we see that this increases by 5 each time, so the slope must be 5. And since if you're going to get 0 hours, you have to subtract 5 from 55 and you get 50. So the y-intercept would be 0, 50 and the slope would be 5. So let's look back at the so our only choices for the slope of 5 is A and C. So we can cross off B and D as any of our choices. And then we see that our y-intercept is 0, 50. So this is our y-intercept. That's why for number 4, C is the answer, and then you can cross off A because A doesn't have any y-intercept. So let's move on to number 5. Number 5 says linear relationships are sometimes, always, or never example directly proportional relationships. Well, linear relationships are sometimes examples directly proportional relationships, like y equals 2x is an example of directly proportional relationship, and it is also a linear relationship. So let's move on to number 6. Number 6 says sketch a graph that represents a directly proportional relationship. Well, in the beginning of this video, I sketched a graph for you guys that is representing directly proportional, and this is this graph, which passes through the origin right here. And then let's move on to 7. 7 says sketch a graph that does not represent directly proportional relationships. I did that for you guys, which is this graph, and then it does not pass through the origin, it goes above the origin. So let's move on to number 8. Number 8 says, does the table shown represent a direct variation? Justify your response. Well, as you see, let's just say that, okay, so this is represent direct variation. As you can see, for every 2 increases, this increases by 1. So that means if you want to get 0, you're decreasing it by 4. So you have to decrease this by 2. So 7 subtract 2 is 5. And since this will have a y-intercept of 0, 5, this is not a directly proportional direct variation because direct variation does not have any y-intercept. So let's move on to number 9. Number 9 says find a constant of variation for the directly proportional relationship represented by the data in the table. And then write the equation that describes the relationship. We can see that that for every for every 4 increase, it's increasing by 0.8. The y is increasing by 0.8. So if we divide this by 4, you get 0.2. So our slope is 0.2. So our k will also be 0.2 because that's a constant variation. So our k is 0.2, and our y-intercept and our equation is y equals 0.2x. And since we don't have any y-intercept because this is a directly proportional relationship. So let's move on to number 10. Number 10 says, which of the equations below are examples of direct variation? Explain your choices. So our examples of direct variation is number A, is option A because this does not y-intercept. Option B is not an example of direct variation because it has a y-intercept of 5. Example C doesn't have y-intercept, so it's also good. And example D also doesn't have y-intercept because if you solve this in the y equals kx method, so this is our original equation, and then if you solve it, means if you take y over here and x over here, 6x, and then you get 0 equals y subtract 6x, and you subtract y, subtract y, you get negative y equals negative 6x, then divide by negative 1, divide by negative 1, you get y equals 6x, and this does not have direct, this is a direct variation because it does not have a y-intercept. So for number 10, the options you can choose are A, C, and D. So let's move on to number 11, which is on the next page, which is page 173, activity 13, and it is a continuation of the activity practice. So let's do number 11. Let's read this problem scenario before starting. So the problem scenario is the number of cups of flour used in a recipe varies directly with the number of cups of milk used in the recipe. For each cup of milk used, 4 cups of flour are used. So let's do this. For each cup of milk used, 4 cups of flour are used. If x represents the number of cups of milk and y represents the number of cups of flour, which of the following graph represents the relationship between number of cups of number of cups of milk and the cups of flour used in a recipe? So since y isn't, so let's see. So for 1 cup of milk, 4 cups of flour should be used. So if x is 1, y has to be 4. So if we see here, if x is 1, y is not 4. Let's see here, if x is 1, y is 4. So this is a good graph. Let's see this. If x is 1, y is 4. This is not a good graph if x is 1, y is not 4. So this is the only option. So for 11, the answer, the choice you have to pick is B. So let's move on to 12. 12 says, tell whether the relationship shown below is directly proportional or non-proportional. Explain your reasoning. Well, as you can see, it's directly proportional because it passes through the origin. So, and for 1, it's right here, and then for 2, it's also right here. So as you can see, it's doubling. As 1 doubles, this also doubles. So the 12 is directly proportional. So let's move on to number 13. Number 13 says, explain how to recognize a directly proportional relationship in an equation, in a table, and in a graph. Well, in a graph, it's easy if it passes through the origin. In the equation, it's because if it doesn't have b or y, or in a table, if they give you 0, 0, and you guys can also do this on your own. So example of a directly proportional relationship in a graph would be if it passes through the origin, and in an equation it would be y equals 2x, and in a table it would be x, y, 0, 1, 2, 0, 1, 2. So this would be example of directly proportional. So that's how you will answer this question. So thank you for watching this video, and in my next video we're going to do the embedded assessment that follows activity 13. Thank you.